In this video, we will build the perfect HDRI dome in Blender, and contrary to many other setups, we will focus on a noise-free and optimized rendering setup, a seamless and color-matched ground transition, and realistic, rich shadows for the perfect integration of your 3D assets. So in this tutorial, I want to show you what I consider is the very best HDRI dome setup that you can build in Blender. And after having watched lots of tutorials on that matter, I found many of those tutorials had problems with certain elements, and all of those I try to address here in this video. So here I built a similar setup, but I built this one here wrong on purpose in order to demonstrate you certain kind of issues that many of the video tutorials about this topic here have. And the first issue is that you end up with a huge amount of noise because the scene is not really optimized. It's not really rendering it in a very smart way, and that's why you can see these very bright dots which appear here, and they will just never really clear up. So that's something that we try to avoid, of course, in our final setup. The next thing is that you can see we have this kind of floor here, but it doesn't really blend seamlessly in our HDRI dome. You can see the colors don't match. You clearly see where the floor is starting and where it's ending. And that's of course something that we also don't really want to have in our final setup. The next thing is that oftentimes I found that many of the other video tutorials that teach you a really weird and strange way to build the shader for the ground plane, and you end up with some very unnaturally bright shadows. Your objects don't really look like grounded in the scene, and that's of course something that we also will try to avoid in our final setup. So here we're now back in our optimized setup, and you can see how much nicer and realistic the shadows here appear. Then also how seamlessly the floor here blends into our dome. And then also how little noise we have here on the tires. They immediately clear up. We don't really get these kind of bright dots and so on. And just overall, the scene here just looks much more realistic. So right now we're using cycles, but of course this whole setup also works with Eevee. And you can see once I switch to Eevee, you get pretty much identical results, and you get all the advantages of using a real-time renderer and get real-time feedback here directly in your viewport. But now without any further ado, let's just check out how we can build this setup from scratch. And I hope that's something that is useful to you. If you like this kind of content, don't forget to subscribe because I plan to release more Blender content in the future. Let's first discuss what are the benefits of using an HDRI dome setup. And for this, let's just render here our scene to just see our starting point. And you can see it's completely black because we didn't really set up anything in our environment yet. So let's change that. Let's just put here a simple environment texture. And then let's just open an HDRI from polyhaven.com, for example. And let's just map that here into the surface of the world output. And you can see now we have something that shows up in our environment, and it's also illuminating our scene and also causing some nice reflections here on the car. So while this overall looks nice, there are certain kind of issues with this setup. So first of all, if you turn your camera around the car, you can see the car is kind of floating in the center of the HDRI. It's not really placed on any kind of floor. And because we don't really have any floor, we also don't really have any shadow interaction. So there's no shadow that's being cast on the floor. So that's one issue. But another issue is that also if you zoom in and out, you can see that your environment doesn't really seem to react to those camera changes. It's basically always the same scaling here in your scene. There's no parallax effects or something like what you would expect in reality. That's because the HDRI here in the environment is infinitely far away, so it doesn't really react to any kind of movements that we do here with our camera. So the fix for this is easy in theory. So instead of using the infinitely far away environment texture, we're just gonna map our HDRI on an actual geometry, because then we don't really have any of the downsides of the environment texture. So for this, let's just create here a simple UV sphere. And down here, we can change the radius. Let's use, for example, 40 meters here as a radius. So it's quite big. Let's just zoom out and see what we have in here. So now we can enter the edit mode. Let's just go to the wireframe view. Let's just select all of the vertices from the lower part of our dome. Let's just scale them down here by just putting them completely flat. And let's just put here the height of 0 so that we just have this completely flat floor plane at the height of 0 meters in our scene. And now as a finalizing step, we can just take here the edges and just move them slightly up a little bit so that we just have this transition here on the side of our dome. Let's just go to the solid view and right click on it and just apply this shade smooth option to just get a little bit nicer shading here on our dome. So now let's check our normals, and for this let's use here the face orientation option. And now we can see our front facing and also our back facing normals. So at the moment we can see only this kind of blue color. That means we're only looking at the front facing normals, and inside they are red. That means those are the back facing normals. We actually want to flip that because later on we want to place our camera inside this dome. So we have to select here our dome. Let's go to the edit mode. Let's select here all of our mesh. Let's just go to the normal and flip those ones in here. So you can see now the outside is red and the inside is blue. And that's exactly what we want in this case here. We can now disable here the face orientation mode. And if we want to see the inside of the dome, we can now use back face culling, and then all the back facing faces will be culled away and we can see the inside of our dome here quite nicely. So now we want to create a new material for our dome. So let's just put a simple emission shader in here. Let's just map that into the material output. Now let's just start rendering and see what we'll get. And as you can see, we have the simple emission here on our dome, which is of course not really what we want to have in the end. We want to be using our HDRI here on the dome. So for this, let's just add here an image texture and let's just choose the same HDRI that we used before and just put this here into the color slot of our emission. So this looks all right, but the problem is we can't really see the inside of our dome anymore. This only works here in this solid view, but once we go to rendered, so to cycles, for example, we can't really see that anymore, and that's why we have to build a shader that does exactly the same thing. So for this, let's just add here a simple transparent BSDF. Let's just place that under this shader in here, and let's just connect this to the material output. And you can see once I do this, it is exactly what we want to achieve, but we only want to have this effect here on the back faces. And at the moment it's applied to the whole dome, so we have to build a simple mix shader. And now we're gonna place here our transparent BSDF in this part of the mix shader and our emission in that part of the shader. And if we connect this now into our material output, you can see we have this half blend between both materials here with the factor. So let's just put a geometry node and set the geometry node here to back facing and feed that into the factor of the shader. And then you can see we have now exactly achieved what we wanted to have. So now you might notice that here our geometry dome is not really lined up with our world environment. So here we have this building, and in the dome we have a completely different building at the same area. So we have to first make sure that both of them here align. So for this, let's just add some mapping coordinates here in our HDRI. And let's just change here the type to object, and then in the HDRI, let's use the spherical projection. And then once we do this, you can see that now with the Z position here, we can change our floor projections. Let's just move that to roughly like this here, -5 meters in this case, so that basically our entire floor is covered with the floor from the HDRI. And then the dome has here our environment projected onto. So now we have to line up here our geometry dome with our world environment. And by trial and error, I can tell you what are the correct measurements here. So for scaling, you have to go -1. And then the rotation, in this case, you have to go -90. And once you do this, you can see that now it's properly lined up. So we have this building, which appears here in our geometry dome at this side. Our sun is basically coming from the same direction. And then also the building here is correct, and the car is both on the left-hand side of this gate. So you can make sure that everything here lines up properly. So So now that we know that both of them are lining up perfectly, we don't really have to see our scene environment anymore. For this, let's just add here, for example, a simple emission shader. Let's just put this here into our output. Let's just give this kind of like this dark gray background, but we don't want to completely get rid of our HDRI. We basically just want to hide the visibility in the viewport. And for this, let's just add a simple mix shader. And also let's add a simple light path node. And we'll put the light path here to camera ray, put this into the factor of the mix shader, put our HDRI here in the upper part and our emission in the lower part. And now if we connect this, we basically keep everything from the HDRI except here the visibility in our viewport. And like this, we can still use the HDRI for illumination and so on. And it's just not visible here in our rendering anymore. Now we're going to be using our environment to illuminate our car, while our dome will only be visible to the camera rays. Because if we zoom into our car here, you can see we have certain kind of issues. And that is that we have this huge amount of noise, which is showing up here, especially at the dark parts of our car. And the reason for that is that we basically use our geometry dome here to illuminate the entire scene. And this is a super ineffective way of doing things. So now let's see what happens if we hide here our geometry dome. And once we do this, you can see now we're using the world environment to render our car because the dome is not blocking this anymore. And you can see we have basically no noise at all. It looks really, really nice. And that's exactly what we will try to achieve in the end. So instead of using here our geometry dome to render and illuminate our car, we only want to have that visible in the parts where we need it. So for example, here in the background, or maybe here in the refractions of the window, but we don't really want to use the dome here to illuminate the entire car anymore. So what you can do is to go here to the Object tab, and then in the Visibility, Ray Visibility options, you can define how the dome here will be used for the rendering. And in our case, we want to basically not affect here our shadows. So once I disable this, you can see that the tires also illuminate because we're not blocking here our environment lights anymore. We also want to disable this here for the volume scatter, for the glossy and the diffuse rays. And like this, we get a quite nice result. I don't want to disable this here for the transmission, because if you take a look here at the window, once I disable this, then basically we're using here our world environment for the transmission rays, and you can see they're misaligning here with our dome environment. So I want to keep this one here enabled. So this here would be a way to do that based on the geometry, but I think the better way in this case is to do that based on the shader. So we will use all of these ones here enabled, and we just go over to our shader editor and try to achieve exactly the same result in there. So now back in our node editor, I want to build the same setup like we did before with the ray visibility. And the node for this would be called the light path node. So let's add this into here. You can see we have very similar options in here. For example, we can define if something is a camera ray, or what we also would need is a transmission ray in order to make the glass here derive from our shader and not from the environment. So we already built a setup where we basically use a transparent shader to have this kind of effect that we can look here through our dome. So what we want to do is to apply the same kind of transparent shader also in the areas where we don't really want to see our dome. And this we're going to be doing with a new mix shader. So what we're going to be doing now is to pipe here our transparent BSDF into the first shader, then the previous mix shader into the second slot, and then the light path is camera ray here into the factor. And if we apply this now here to our material output, you can see we have now basically exactly what we achieved before. So there's no noise anymore here on the tires because everything is deriving from our world environment except what we see here in the background. You can see there's one issue that is here the things that we see in our refractions. You can see they are not lining up because our world environment is infinitely far away, and we want to have here the correct refractions from our environment dome. So we have to expand the setup here slightly. So what we need to do is to also factor in here this is transmission ray in order to get the correct factor here for our mix shader. And this we can just do with a simple math node. We will use here the add option. And now we're gonna pipe here our is camera ray into the first value, is transmission ray into the second value. And now if we pipe this one here into our factor, you can see that now here also our refractions in the window, they now appear correct. So now let's quickly step back and see what we achieved already. And so far we built this nice geometry dome setup, which has the result that our car is now not floating somewhere in space anymore. And if you move in and out your camera, you get this nice parallax effect here that looks very realistic. It doesn't look anymore like only the car is scaling up and down and our infinitely far away environment just stays completely in place. So this is fixed. And also because we use some smart way to build here our shader, we don't really have any problems with noise and we have a very optimized way here of rendering the thing. But what we're missing is, as you can see, there is no shadow here on our floor, and that's why our car doesn't really look fully integrated yet. And that's what we're going to be dealing with in the next step, how we can get some nice interaction here between our floor and the car, how we can get some nice shadow, how we could even get some kind of reflection or bump mapping here on our floor. And as said, that's what we're going to be discussing now in the next steps. So the reason why we don't really have any shadows is because at the moment we just use this fully emissive shader inside. And this is not really reacting to any of our light information. So basically it doesn't really allow any kind of shadow on it. So we have to layer a different shader here on the floor area. And before we can do that, we have to create some UVs in order to layer a second shader here on top of our current emissive shader. So now with our environment dome selected, let's move on to the wireframe view. Let's enter the edit mode. Let's just select all of the faces in here, make sure that everything is selected from all areas. And we're gonna grow the selection until we have everything selected apart from our floor. Let's invert that now. And now we want to go here to a top view and we will go to UV and say project from view bounds. Once we do this, you can see that now we have this perfect planar UV from the top here that just has UVs here for our floor. And now we're gonna invert everything and let's go to the top again and let's do the same thing again. So now with our inverted faces still selected, let's go in our UV editor, select all of the UVs. Let's just move them up here to the 1 position. So I will put a 1 in here. And we will also go inside and scale everything to a size of 0 so that they don't really get in our way. And now if I just select all of the UVs, you can see we have the UVs for the floor here nice in the center and everything else is just nicely tucked away up here in the corner. So here we're back in our node editor and we have our setup that we built earlier for our environment dome. But what we want to now add is a separate shader here for the floor. And for this, we have to add a new mix shader inside. And we're gonna pipe this mix shader, which we built earlier for our dome, into the first slot here of the mix shader that we just created. And we're just gonna pipe that now into our material output. And it gets darker because we're just mixing it with black for now. So let's just add a new principled BSDF, for example. And let's put this into the second part here of our mix shader. And now let's give this here a kind of reddish color so we can very fast see where this is. And you can see now it's mixing everything here with a 50% factor. For now, let's disable here the reflections by just putting the IOR to a value of 1. And now we can use a gradient ramp here for our factor that uses the UVs of the floor to basically just blend in the floor around the car. And all the other parts we will keep here our emissive shader. So in order to control our factor, let's add here a simple gradient texture. and put this into our vector. Let's just move down a little bit so we have a bit more room. So the gradient texture, we would need to create here a simple node setup in order to place our gradient, and we want to be using our UVs instead of the generated texture coordinates. So let me just put this inside here. And then we want to put the gradient texture here to a quadratic sphere. So now we can play here with the settings a little bit. I found out that by using an X and Y scale of 2 and then a negative X and Y offset of 1, we can get a nice gradient that's concentrated around here the center. And you can see that now we would be placing our floor around our car. Now we can also add here a simple color ramp in between and just define how our shader here should be placed. By just moving this slider here around, you can place basically the floor shader and you can define the size of your floor. For now, let's just use here a constant because I want to artificially keep a very harsh transition in order just to make sure that we have the correct colors and so on later for the floor. So now let's quickly reorganize here our graph a little bit. And now we can go inside and basically pipe the texture of our emissive shader. We can also pipe that into our principled BSDF. And now you can see we have two things. First of all, we have a shadow here on our floor because we're using a principled BSDF shader. So this allows to receive the correct amount of shadows. That looks great. But you can see there is a clear problem, and that is that we have a texture on the floor now, but the colors are not matching, right? So we have a very clear difference in terms of color tone, and that's what we have to address here in the next step. So the reason why the floor in our principled BSDF looks different than the floor in our emissive shader is because the emissive shader doesn't receive any lighting from our environment, while the principled BSDF does receive lighting. So we're basically piping in the color from the HDRI on the floor, and then on top of that we're reapplying the lighting from the environment. So we have kind of like a double lighting situation here going on. We have to remove the additional colors which are added here on the floor texture from the HDRI for the principled BSDF in order to match both color tones. This might sound more complex than it actually is, so let's just break it down in very simple steps. So step 1 is to display the amount of light which is coming from our environment and illuminating our floor. And for this, we're just gonna disconnect here our HDRI, and we're gonna put the base color here to complete white, so a value of 1 and a saturation of 0. So this is now the amount of light which comes from our environment and is illuminating our floor. So next step is to sample or pick the color value from our floor. But at the moment we use color management, so we have some tone mapping going on. And that means we can't really pick the correct color values from the floor because there are some additional color corrections, adjustments, and so on happening here in the color management. So we have to disable this first. For this, let's just switch here the view transform to standard, and the look should be set to none. And then the exposure, gamma, and so on should all remain at the default values. So now we're displaying the raw linear colors without any tone mapping. So we could now pick those colors. So for this, let's just choose here a simple RGB input, and let's put this here for now. And with the color picker, we can now pick here the color from our floor to sample our illumination. And once we do this and we check those values, you will see that they seem to not really be picking the correct values because it's just pure white color, no hue, no saturation, no anything. And that's because the colors here at the moment are clamping because they are too bright to be displayed correctly on the monitor. And that's why the color picker cannot also cannot really sample the correct colors. So since the colors are too bright to be shown correctly on the monitor, luckily the fix for that is quite easy. We can just easily go here to our environment setup that we built earlier, and we can just reduce here the strength of our illumination. You will see once I go down here with the strength into some much lower values, we will be able to have colors here on the monitor which are not completely clamping to white, and those colors here we could pick. Let's choose an illumination strength of 0.5, and then let's go back here into our object, and now we are able to sample those color values in here. So you can see that now we have some kind of values and it's not completely clamping to white. The issue we now have is that the illumination which we sampled from our floor is based on an illumination which is too dark because we went into our environment and we here reduced the emission. So let's go back by putting that to its original values. That was 1, so we have to multiply that with 2. So now we have the bright colors here again, and now back in our shader for the floor. Since we multiplied our emission with a value of 2, we have to also multiply here this value with a value of 2. So let's do that. And now we have the correct color value here, which we couldn't sample because those are out of the range to be displayed on our monitor. But using this simple trick to reduce temporarily the emission of our environment and then sample it and then bring it back up again and then multiply that on the value, we can then get the correct illumination which is added on our floor plane. So now we can enable also our tone mapping again. So let's put this one back to filmic and the look to medium high contrast, how I had it before. And now we are able to divide our HDRI texture with the color that we sampled here. And then we should get an exact match between our emissive shader and our principal BSDF floor shader. So now let's first put back here our original HDRI on the floor. And again, you can see the colors are not matching. But now we have the illumination sampled here, which is added on the floor, and we can now divide our HDRI with this color value. So let's use here a simple mix color node, and let's pipe here the color that we sampled into the B slot and then our HDRI into the A slot. And let's choose here the option to divide the color and then use a factor of 1. And if we now place this node into our principal BSDF, you can see that now our floor is perfectly matching with our emissive shader, and we have now created a completely seamless transition. So now that we have perfectly matching colors here for the floor plane, let's just disconnect this again and take care of the blending of our floor plane, because at the moment you can see here the interpolation pipe for the color ramp is set to constant, and we can use a much nicer blending type here, for example, a cardinal. If we do this, you can see we have a much broader and nicer blend here between our floor plane and our dome environment. And if we now reconnect here our base color, you can see we get even nicer blending, which is happening now for our floor plane. So what we can also do, of course, is to add some reflection. For this, let's just reduce here the roughness temporarily and increase the IOR. And you can see as soon as we do this, we have reflections which are here appearing on our floor. And this for certain kind of floor materials, of course, can help a lot with the integration. Here in this case, the floor is rather diffuse, so I think I would be more subtle with this, but I just show you how this would work. You can increase then the roughness to just blend this here nicer. Let's use, for example, a roughness of 0.5. And then we can see we have this kind of like broad specular, which is then moving also over the ground plane. And this makes the whole scene here also look a bit more realistic than if there's basically no reflection at all on our ground plane. You just have to be subtle. So if you increase this IOR here too much, you can see that the blending of our floor plane and our dome environment doesn't work anymore, because we have all of this additional reflection added on our ground plane, which is not added on our dome environment, of course, because this is just an emissive shader. So better just be a little bit more subtle here to get some nicer and more believable effect. But I think like this, it works basically quite nice. We have this broad specular here on our floor, and this all makes the scene appear much more alive and much more realistic. So now we're almost finished. We just have one remaining issue, and that is if I now take here the dome and I rotate it around. You can see I rotate the dome, but it doesn't really seem to update the shadows. And that's because our lighting is derived from our environment. And this one is not rotated when the dome here is rotated. So we have to basically link those two. So back in our node editor, I opened already the environment settings. And here you can see the HDRI that we're using for illuminating our scene. At the moment, you can't really see that because we hided it before. So let me just unhide this here by just connecting the emission past this mix shader. You can see that now we have our environment setup, which is aligned with our dome. So that's why at the moment it looks correct. But if I go in and I rotate now here the dome, you can see that our environment doesn't really rotate along with it. And that's why the shadows then in this case don't really match anymore. So that's what we have to change now. We have to align here the rotation of the dome also with the rotation of our environment. So for this, we just have to add some simple mapping coordinates here for our HDRI. Let me just switch this to Eevee because rotating the environment is a bit slower under cycles. And now you can see that if I use the rotation, then here my environment will change. And you can also see that the shadow is then changing together with my environment, of course. So now we only have to link the rotation of our dome with the rotation of our HDRI. So now we just want to add a driver to our mapping node. We want to use the Z rotation. So we just right click here, add a driver. And now we want to select here our dome geometry. And this one in my case is just called sphere. And then we want to take the Z rotation. Once we exit here, we select our dome and we start to rotate it. You can see something is happening, but it seems that the rotation here is inverted. So let's just go inside and just add a minus in front of this variable here. And now if we rotate this, you can see that now everything here properly lines up and everything seems to working nicely now. So now that we know that our environment here is working, we can just reconnect our mix shader to hide it again. And this basically here concludes our setup. So now let's check out here our final result. And you can see we have this nice geometry dome with a car that's very nicely integrated here on our ground plane. We can get a very good and realistic looking shadow. We have even some bump mapping here on the floor and some moving speculars from the HDRI. And since we try to build the scene here as performant as possible, we also don't really have any kind of noise here, and everything works and renders quite fast. And lastly, we just linked here our dome with our environment. So if I rotate this, you can see the shadow updates and everything here works quite nicely together. So this concludes this tutorial. If you like this kind of content, I suggest you subscribe because there will be more Blender tutorials coming up in the future. And I also invite you to check out my Patreon where you can find a whole course on car rendering, download all of my scene files and find lots of other additional goodies. So check that out if that's interesting for you. Otherwise, see you next tutorial. Take care and see you soon.